Smart lighting systems. Arduino Cable. Arduino UNO R3. Male-to-male jumpers. Male-to-female jumpers. LED of 5 mm. 100 ohm resistor. BH1750 light sensor. Breadboard. Refer the circuit diagram provided to make the following connections. Arduino UNO R3. BH1750 light sensor. This is the code for the smart lighting systems. First, we need to include wire.h library, which basically the for I2C protocol which is used by the light sensor. Then, declare the variables which would represent the corresponding Arduino pins, which are being used by the light sensor and the LED, in the code. Here we also need to declare the address of the slave. The LED is connected to PWM pin for variable output, which in turn provides dimming of LED. Here we also need to declare an array for storing the output of the light sensor. The void setup function is used to initialization. Pin mode is used to initialize the Arduino pins as input or output. Thus, the 9 pins controlling the LED are initialized as output. The output of the LED will depend on the PWM, which in turn will depend on the output of the light sensor. I2C protocol is initialized. Serial transmission is initialized with the baud rate of 57,600. BH1750 initialization is an initialization function and the argument required is the address. In this function the transmission is started with the I2C slave using the command wire.begin transmission and ended with wire.end transmission. BH1750 read is another function whose argument passed is address. In this function the master requests the data from the client by using the command wire.request from address, 2. Here 2 is the quantity of bytes requested by the master from the slave. Variable I is used for the array. So if the bus is free and data transmission is possible, then the first data will be stored in buffer where I equals 0 initially using the command wire.read, and then the value of I is incremented and the data is returned. The void loop function acts as an infinite loop and also the function that is equivalent to the void main function of other programming languages. In this a 16-bit variable is declared named as val. After that, the BH1750 underscore initialization function is called. After doing so, the data which is stored in the array is compared with 2, and if it is 2 then that data is stored in the 16-bit variable name val. For storing this data into 16-bit variable from an array BCD mapping is done and then it is divided by 1.2 for accurate videos. After reviving the data on the serial monitor, the loops are made depending on the output. For doing that also mapping was done and the value coming from the light sensor, which is from the range of 0 to 65,535, was brought down to 255 to 0. For easy calculations, that is for 0 it will show 255 and for 65,535 it will show 0, The net value is used as condition for the if-else loop. In the first loop, if the data coming from the sensor is greater than 252, then the LED will glow with full intensity and the data full intensity is displayed on the serial monitor. Similarly for half intensity, but this time there will be two conditions which are used with the logical and meaning that both should be satisfied at that time. Only the LED will be at half intensity. Lastly, if the output of the sensor is less than 235, then the LED will glowing and it will display zero intensity.